This is unreal. Technology is giving a very tough competition to destiny. While many people think that the advancement of science is a bane to humanity, science is very busy proving them wrong. Behold the magic of science. Let's say if someone loses an arm in an accident or disease, these mind-controlled prosthetic robotic arms can actually compensate for that loss. In this video, we'll be looking at how prosthetic robotic arms can be a lifesaver. So watch this video till the end. Hello, and welcome back to the AI universe. Don't forget to subscribe to our channel and press the bell icon to never miss an update on the new things we bring for you regarding the tech and the trends, but also the vital difference between the haves and the have-nots. That being said, let's begin our video. More than 1 million limb amputations are done each year owing to accidents, war casualties, cardiovascular illness, cancers, or congenital defects in today's society. But technology has a solution for that: prosthetic robotic limbs. Robotic prosthetic limbs are a well-established research topic that combines advanced mechatronics, intelligent sensing, and control to restore higher-order sensory motor functions while keeping the physical look of an amputated limb. These technological marvels are projected to replace an amputee's missing limbs, restoring lost capabilities while also creating a pleasing look. Sensor technology has advanced significantly in recent decades, resulting in substantial contributions in this field. Much of the work is still in the research stage, and further research and development work is expected in the future years, with the ultimate objective of creating a device capable of producing human-like motions. Biomechatronic prosthetic limbs, in contrast to non-robotic artificial limbs, which are normally composed of plaster and steel, use stronger, lighter, and more flexible composite materials, making them more natural to wear. These combine several advanced technologies. Biosensors detect a person's desire to move in a certain way by receiving signals from their neurological or muscular systems, and mechanical sensors collect data on the present location of the prosthesis. Specifically, bionic arms are intelligent prosthetic limbs that communicate with the body using cutting-edge technology. They detect and transform naturally occurring electrical impulses from muscles into movement using specific sensors. The sensors in bionic arms are tuned to the user's strongest muscle impulses, and they are custom-built to match the residual limb. A bionic prosthetic arm requires a lot of work, and the technology has advanced tremendously over the years, from lightweight and durable materials to cutting-edge circuitry. You will be surprised to know how these devices can put color into someone's life. Let's look at an example. Nathan Copeland was nearly completely paralyzed by a car accident that fractured his neck when he was 18 years old in 2004. Copeland, however, used a robotic arm controlled by electrodes implanted in his brain to shake President Barack Obama's hand in 2016, after opting to engage in the experimental study. Copeland's journey has been awesome. A team at the University of Pittsburgh was looking for a volunteer to see if they could learn to operate a robotic arm only by thinking about it. This type of brain-computer interface research has been used to investigate anything from restoring motion to paralyzed patients to designing a new generation of prosthetic limbs to converting thoughts into text. They needed a volunteer, and Copeland was ready to check his fortune. Doctors hooked lentil-sized electrode arrays onto his motor cortex and somatosensory cortex shortly after. These would scan his brain's electrical patterns, indicating his desire to move his wrist and fingers. These impulses would be translated into control of a robotic limb that rested on a vertical stand behind him in the lab through a brain-computer interface. Copeland started driving 3 times a week from his home in Dunbar, Pennsylvania, to Pittsburgh for lab testing. He was able to make the robot move spheres and grip cubes simply by thinking about it after 3 sessions. To people like Copeland who had no hope left for their recovery, this technology has become a blessing from God. Let's understand how these devices really work. Sensors that monitor muscle electrical impulses and transform such contractions and signals to diverse motions connect the mind to the prosthetic arm. They aid in the improvement of feeling, bodily integration, and control. Bionic arms are attached to the body via a bespoke compression cup with skin contact sensors. Bionic arms are an advancement above prior technologies that needed users to retrain their muscles in order to execute activities. Now, people just have to normally move their arms as they are of blood and flesh. The technology can do the rest of the magic by receiving nerve signals. To put it simply, the brain's motor cortex sends out control signals to the nerve stubs. Then a surgeon reroutes the nerve terminals that govern the motion of arm joints, like the elbow, wrist, and hand, to a functional muscle group, such as the chest muscles. As a result, the brain signals reach the chest. Electrodes are inserted on the surface of the chest muscles to read those impulses and operate the bionic arm. Each electrode is in charge of one of the 6 motors that move the joints of the prosthetic arm. As a result, when the nerve terminal receives a signal, the chest muscle to which it is attached contracts. That muscle's electrode detects the movement and moves the limb accordingly. Because it can pick up precise electrical impulses from muscles and transfer them to activities like gripping motions, bionic prosthetics technology has grown more intuitive. Movements are linked to the muscles that would have carried out the action before the amputation. Nerve connections are also becoming possible, allowing for more accurate function and the capacity to perceive motion and other feedback, such as grasp on an item. The sensors on the bionic arm are electrodes that contact the skin and use electromyography to capture muscle activation. Moreover, these limbs are quite flexible. The prosthetic device may be readily removed and reattached without impacting its functionality. Despite this advanced technology used to make bionic prostheses, you may still require therapy to strengthen the muscles themselves. The performance of bionic arms has been enhanced throughout time, with users being able to alter grip strength to manipulate things of various sorts and sizes. An awesome customizable feature is included in this. With just a click of a button, you can change how it works. Some arms use vibrations, beeping noises, and flashing lights to communicate with you about what they're doing. The majority of bionic arms are battery operated. Other than charging, they need a little bit of cleaning regularly to retain their maximum potential. Bionic arms are normally splash-proof but not waterproof, but waterproofing coverings can be added to some. You may also be able to personalize the arm to meet your preferences. Let's come back to Mr. Copeland. After the operation, Copeland could feel anything the robotic hand touched as if it were his own fingertips, according to the team. Over the years, he'd learned to control his hand with his thoughts while monitoring what it did in response. It's the first time a BCI for a robotic prosthesis has combined real-time motion controls with touch. It's also a major step toward demonstrating how BCIs may help people get around paralysis. Now let's go to another person and see what he has to say about it. Meet Johnny Matheny, a resident of Florida. This futuristic technology has also been applied to him, and he is dealing with it quite successfully. He thinks he lives in the future and cordially thanks the scientists for building a life-saving device like this mind-controlled prosthetic arm. He lost his hand to cancer, but science gave it back to him. His arm was created as part of the Johns Hopkins Applied Physics Lab's Revolutionizing Prosthetics initiative. The Defense Advanced Research Projects Agency, or DARPA, is funding the study, which aims to develop prostheses that are controlled by neural activity in the brain to restore full motor function. Prosthetics for upper arm amputee patients are a focus of the initiative. For the time being, the electrodes must be wired to the brain-computer interface, and placing the electrodes in the brain necessitates invasive brain surgery. Furthermore, each electrode has a finite lifespan, requiring surgical removal and replacement on a regular basis. But this technology is evolving. Experiments on BCI technology have been going on by many reputed companies like Elon Musk's Neuralink. His initiative has seen quite a success and waits for FDA approval. But what do you think about this technology? Does this mind-controlled prosthetic arm fascinate you? Do you think that medical science can normalize this technology and make it affordable? Well, it is quite a possibility. However, don't forget to convey your opinion about it in the comments. That's it for the day, guys. We hope you have enjoyed the video. Make sure to like the video and subscribe to our channel for such interesting topics. And we'll catch you in the next one. Until then, peace.